Okay, folks, here we go with checking your page 265 answers. By the way, I found that my camera is cutting me off at 30 minutes, so I need to try to keep these short. Might break things into two parts, just be aware of that. Also, I am not able to check every assignment in glorious detail. I'm looking at your papers, skimming through, see if it looks like you've got the right idea. Sometimes I slow down and take a closer look if I see issues, but I'm not checking your papers totally. If you get a 4 in RenWeb, that does not necessarily mean that everything was correct, or even that 75% was correct. It could be worse than that because maybe I didn't see your paper close up. So just be aware of that. In the meantime, here is page 265. The answers. I'm going to run through this fairly quickly because I think synthetic division is pretty simple once you get the hang of it. So, and this is the class code for Google Classroom. So far, at this point, unlike most of the other teachers, I am not using Google Classroom. I simply haven't had time to look into how to use it yet. Maybe I will, maybe I won't. Right now, I'm happy with the way we're doing this through RenWeb, emails, and YouTube videos. So we move on. Okay, number 2, just a quick rundown of the procedure. We've got our polynomial here, we're dividing by x plus 1. I bring down just my coefficients. The invisible coefficient here is 1. I bring it down. -2, +2, +5. Change the sign. If this is +1, I put a -1 over here. I will change it to a -1, stick it in the box. Then just bring down this first coefficient. At that point, I call this prepping the patient. The patient is now prepped. Now we dive into the actual procedure. You take this guy you just brought down, multiply by -1. We go diagonally and put 1 times -1 here. We now add, get -3. Then repeat. -3 times -1 being +3, put it here. We add, that's 5. Always add. It's 5 times -1 is -5. Add. We of course get 0. What does that imply then? That tells you that your final result is 1x squared minus 3x plus 5 with a remainder of 0, so we don't care. We don't need to write remainder 0. That's kind of silly. That is our quotient. How do we know it starts with x squared? Because x cubed divided by x is simply going to be x squared. So you simply take that exponent and chop it down by 1, and that's your starting exponent down here. And that's it. We now move on to number 4. Number 4, already set up here for you. Everything's pretty straightforward. We're dividing by a -4, so I'm going to put a +4 here. Bring down the 1. 1 times 4, put it here. Add 15 times 4. What did I do? That doesn't make any sense. What in the world did I do? 1 times 4, 4, 15, 15, 4 times 4 is 60. I do not know what I was thinking there. That's going to be a 60. 60 minus 19 being what? 41 rather. So my answer here was incorrect. It's x plus 15 with a remainder of 41. Confirm that. And folks, by the way, that is correct. If you find that I make mistakes, I don't have you guys sitting there telling me when I messed up. So if I make a mistake, please email me, let me know. This time I caught it, and we're good to go. I don't know what I was thinking there. All right, moving on. Let's see, continuing. Number 6. What was that? Number 6. Notice here, please, we've got the x to the third, x to the second. Where's x to the first? There is no x to the first term. We have a missing term. So when we bring down the coefficients, bring down your 1, your -2, your missing term of 0, and then your 8. We're divided by x plus 2, so I'm going to put a -2 in the box. Now we dive into the process. Bring down the 1. The patient is ready to go. 1 times negative 2 is negative 2. Add, we get negative 4. Multiply, we get positive 8. Stick it over here. Add, we get 8. Multiply, we get negative 16. Stick it here. Add, we get negative 8. Negative 8 becomes your remainder. So we started with x to the third. So your first term is going to be an x to the second term. Therefore we have 1x squared minus 4x plus 8, remainder negative 8. And yes, you can express that as minus 8 over x plus 2 if you want to, but this form is just fine. This form is really nice, but the book is assuming that you're using remainders instead of fractions. We move on to number 8. Number 8 has that additional little glitch in it that we're not only missing the x squared term, we're also missing the x to the first term. We have to have 2 zeros here. If you put only 1 0 there, it messes everything up. You have to have 2 zeros for the y squared and y to the first term. They're both missing. So there's your procedure. If you need to study that in more detail, you can hit pause and look at it, but we're moving on. Oh, notice please, the plus 3 means I put a negative 3 over here. I bring the 6 down and then start multiplying, adding, until we're done. Our final result, there it is. Pause that, compare with your answer on your paper, and we move on. Number 10. 10 has a boatload of missing terms. We had, let's see, that'd be 0, 1, 2, 3. So it started with x to the 4th. No, x to the 5th, 4th, 3rd, 2nd. Oh, okay, I probably didn't look at that, negative 32. Okay, so that's your x to the 0, 1, 2, 3, 4. So we started with x to the 5th. Because we started with x to the 5th, our answer will start with x to the 4th. You see all the work shown there. This one gets no remainder. So there we have our result. By the way, what does this imply? Because there's no remainder, that means that x minus 2 was a factor of our original x to the 5th minus 32. And that is the other factor. We move on. Number 12, we had a couple of missing terms. There was a missing term here, we filled in a 0, and a missing term there, we filled in a 0. This is the one I warned you about in class the last time we met in person, and that was that it was going to have a huge remainder of 6,958. No, you were not wrong. That is correct. I did see on a couple folks' papers some careless arithmetic mistakes. I think one person had a 7 there. Just check your arithmetic. Be careful. And so your final result is 3x to the third plus, and remainder is 6,958. And that's it for number 12. Number 14 is correct. I would encourage you to look back at number 13 and find out why it is not correct. See if you can find the mistake and fix it for number 13. Okay, that's it for the old stuff. Now, we go on to the new stuff, and I did not check the starting time. I don't know how much time I have before my camera cuts me off. Oops, I really have no idea what time I started. Not real good, but I think we can run through this next section pretty quickly. I am now launching into section 6.6, starting at page 266. 266. Oh, interesting coincidence there. Never noticed it before. All right. The difference this time is we're dealing with not just simplifying expressions and doing divisions. We're dealing with solving equations. It's a different situation. The first example they give in the book is not a real good one because there are easier ways to do this one. But we're going to use this to illustrate the concept that you will have to use on many of these problems. So the trick here is we look at the LCD of a 3, a 6, and an x. Your LCD will be 6x. All right? Given that, we will now, because we have an equation, we have the privilege of doing something really cool here that we can't do with ordinary expressions. We have the privilege of multiplying both sides by the same thing. So we're going to multiply both sides by the LCD of 6x. Why? Because that will kill off all the denominators. It's actually a pretty cool concept. Here, 6x times 2 over 3. Well, think of that as being 6 over 1, and you learned back in elementary school how to deal with 6 times 2/3, and the 6 over 3 cancels, becomes a 2 times 2 is 4. So, here think like this. 6 over 3 is 2. 2 times that old 2 is 4, 4x. Plus, this time the 6's cancel. That leaves us with 5x. Here, the x's cancel. That leaves us with 1 times 6. And now we have a very ordinary equation, 9x equals 6, divide by 9, excuse me, 6 over 9, reduce that please to 2/3, and we are done. That's all there is to it. And we move on to a new example. A somewhat more meaningful example for example 2 on page 267. We have x minus 1 over x minus 5 equals 4 over x minus 5. And please show me what you're doing. Yes, this can be done by cross multiplying, but that's not what I'm encouraging you to practice here, because there's later problems we're going to see where cross multiplication will not serve you well at all. So let's not cross multiply. Let's go ahead and do it by the same method we just saw, multiplying both sides by the LCD. The only question remaining is, what's the LCD? How do you deal with that? Well, I think pretty clearly here the LCD of an x minus 5 and an x minus 5 is x minus 5. So we're going to multiply by x minus 5 on both sides. This guy turns out to be way too easy. Did I copy that right? It seems so easy. No, I copied it right. So if we do that, these x minus 5's cancel. I'm left with just x minus 1. On this side, the x minus 5's cancel. I'm left with just 4. Add 1, x equals 5. Done. But not really. Watch out for this. In this process, there are times when you will do everything right. You will make no mistakes. Everything is cool, except you still get an answer that is false. In this case, x equals 5 does not work. Do you see why? Hint, hint. What if I put my answer of x equals 5 in for x? 5 minus 5 is 0. Wait just a moment. You can never ever divide by 0. So x equals 5 looked like your correct answer, but it's actually illegal. X minus 5, or I'm sorry, x equals 5 is an erroneous solution. Erroneous, meaning it's an error. Not an error you made, but it's an error nonetheless. It is an erroneous solution, so the solution to this one is there is no solution. In the homework, you will come across one equation, I believe just one, that has no solution. You must show me on your paper the reason why there is no solution. You have to do the work, end up with x equals 5, and then tell me that 5 can't work because it puts 0 in the denominator. I need to see that. I don't want to see you simply write, number 36, no solution. No, not good enough. I need to see your reason. Work it out. Show me why there is no solution. I also want to see evidence that you are actually not cross-multiplying. I want to see evidence that you are actually multiplying by the LCD on both sides. Show me that step so I know that you're doing this the way I want you to do them. Example 3, I am going to let you look at example 3 for yourselves. Let's see, there's a trick to number 3. You end up getting a quadratic equation. Once you multiply by the LCD on both sides, you're going to end up with x squared minus 4 equals 0. We know how to handle that. X plus 2, x minus 2. So your solutions would be negative 2 and positive 2. But if you look at the original equation on page 267, example 3, you'll see that if you put in 2 for x, you're going to get zeros in the denominators. Illegal, erroneous root. So which one works? Negative 2 is fine. Positive 2 does not work. Your only solution is negative 2. Watch out for erroneous roots. Okay, I'm going to let you again study example 3 on your own. It's not a complicated example at all. Let's take a look at example 4. Example 4 is one where other methods, such as cross multiplication, will fail you. All right, let's see what we're going to do here. This one has a very simple LCD. What's the LCD of a 1 and an x and a 1? The LCD is x. So we multiply both sides by x. Multiply by x. Be careful. What do we get here? X times x, x squared, plus. Here the x's cancel, leaving me with just 6 equals 5x. Ooh, subtract 5x from both sides. X squared minus 5x plus 6 equals 0 now. We know how to handle this. We've been doing these a lot. Back in the days before the virus, we were doing these. X minus. We need two things that multiply to give 6, but add to give negative 5. They would clearly be 2 and 3, because negative 2 times negative 3 is 6. Negative 2 minus 3 is negative 5. Your solutions are therefore 2 and 3. Are they both legal? We go back to the original. The only thing x is not allowed to be would be a 0 right there. We got answers of 2 and 3, so they are both good. We get 2 answers. We move on to the next example. Let's just kill that. The next and actually last example in the book is a somewhat uglier one. 2 over, I hope my video did not cut me off already, x plus 5, copy correctly, plus 1 over x minus 5, and I bet I know what the next denominator is going to be, yep, equals 16 over x squared minus 25. Guess what your first step has to be? You got it. You've got to factor this, either in your head or on your paper. Everyone knows how to factor this guy, difference of squares. It's going to be x plus 5, x minus 5, very old stuff. Now, what's the LCD for an x plus 5, an x minus 5, and an x plus 5, and an x minus 5? Yes, you are right. The LCD is x plus 5 times x minus 5. Multiply by x plus 5 times x minus 5. Over here, what happens? One term at a time. Multiply these guys. The x plus 5's cancel. What are we left with? 2 times x minus 5, otherwise known as 2x minus 10. 2x minus 10. Plus, here, the x minus 5's cancel, leaving me with 1 times x plus 5. Well, that's easy. X plus 5 equals. Here, oh glorious, the whole thing cancels. We're left with nothing but 16. From there, it's pretty easy to solve, right? 2x plus x, that's 3x. Negative 10 plus 5 is minus 5 equals 16. We will now add 5 to both sides and divide by 3. X is 7. We go back to the original, make sure 7 is legal, and there's no problem here. By the way, if we had gotten an answer of negative 5 or positive 5, then it would be illegal because you can't have 0 in the denominator. But we got an answer of 7, so there is no problem. 7 works fine. We're done. That was the last example in the book. Of course, these are in the book. If you want to see more detail, you can look at the book. That was these examples. Last two are on page 268. Your assignment. Let's do page 269. Page 269. Numbers. I'm not going to make it as rigorous as it would be ordinarily. Let's go numbers. How about if I back way off? and do 4, 8, having a hard time deciding here. Let's do this. Numbers 3 through 27. Well, I'm going to back off on that decision because I believe I've already produced a video for the other class for page 269. So I'm going to stick with the same thing I gave them, which will be 2 through 26 even. 2 through 26 even. In the future, I may be lightening up some on the assignments, but for right now, that's it. Looking at the, there it is at the clock, I should have no problem getting this posted by 3 o'clock. So consider this to be due Thursday by noon. Anything submitted after noon tomorrow will be counted as late. So there you have it. Please try to refrain from sending me emails that are of no great significance, but if you have an important question you cannot figure out for yourself, go ahead and let me know. But try to minimize the amount of emails you send me because I've been overrun with zillions and zillions of emails, and it's taking me forever to process them all. So just stick with the basics. Shoot me your pictures of page 269 and do it by noon tomorrow. That gives you plenty of time. In fact, that gives you about 23 hours to get it done. I think that should be adequate. All right, that's it for now. Thank you, and see you next time.